Welcome back to MPB, Learning Here with me, Ms. Killen. We are into our Unit 7, Working with Quadratics. We're on Lesson 3. We are using a table to graph a quadratic. I can use tables to help graph a quadratic function. I'm looking at FIF7A. So let's just go ahead and see what we've got. Lisa's at the old fishing hole. The table below shows data recorded from Lisa jumping off a tree limb into the pond. The limb is 40 feet above the ground. The data will show Lisa's height with respect to time. It can be modeled as h of t equals 40 minus 16x squared, where t represents my time. So at 0 seconds, she's on the limb. She hasn't quite jumped yet. So she jumps off, and at a quarter of a second, she's at 39 feet, and she keeps going down until she gets into the pond at 1.58 seconds later. All right, so let's see. Now, what I want to do and what she wants us to do is she wants us to graph this situation. So let's go right on into it. On my y-axis, I'm going to have my elevation in feet. On my x-axis, I'm going to have my time in seconds. So I'm going to put, here's my zeros. I've got 0.25, 0.50, 0.75, 1, 1.25, 1.5, 1.75, and there we go. So my feet, we've got 40, 38, 36, 34, 32, 30, 28, 26, 24, 22, 20, 15, 10. I know I skipped 5, guys, but I'm running out of room, so I do apologize, and 5. So we start with Lisa right here at 0:40. And then she starts to come down like this. So you want to make sure that you understand we're only using half of our parabola. Now, Ms. Killen can't draw a curved line to save her life, but if we could imagine that this would be our vertex, and then this is what the rest of our parabola looks like. So sometimes we're only going to use portions of those parabolas, depending on what the context and what the passage is about, depends on what part of the parabola that we're going to use. So we're only having to use this portion right now. All right, let's look at some more. It says, Michaela is standing in the park and kicks her new soccer ball up into the air. The ball travels at an initial velocity of 32 feet per second. The equation h of t equals negative 14x squared plus 32t models the height of the ball, h, at any given time, t. Complete the table first, then graph all of the data on the grid. So here we go, and we have already finished our data on our table. So what I want to do is I want to graph this data, then I want to answer the 3 questions. So on my y-intercept, I have my height, and it says in feet. And on my x-axis, we have my time in seconds. So my seconds are going to go 0, 0.25, 0.5, 0.75, and 1. Then I have 0.125, and I have 0.15, 0.175, 2, 2.25, and 2.5, then 2.75. Now let's look at the height. At 0, 0, it's right here. Then we go up, and I'm just going to use the points on our table because there's a lot of in-betweens and I don't have that much space. So I'm going to put 7.125. I'm going to put 12.5. Then I have an 8 right here. I'm going to have a 1.175 here. I'm going to have a 16, nope, I got a 13. The next one is 13, so I'm going to have 13.125. Then we have our 16.125. We have our 16.5, our 18, and 18.125. All right, so let's go ahead and graph this. So here I am here, and then at half a second, I'm at 12.5. At 3/4 of a second, I'm at 16.125. At 1 second, I'm at 18. At 1.25, I'm at 18.125. At 1.5 seconds, I'm at 16.5. At 1.75 seconds, I'm at 13.125. At 2 seconds, I'm at 8. At 2.25 seconds, I'm at 1.175. And then at 2.75 seconds, I'm back on the ground. So if I connected them, they would look like this parabola. So for this instance, I'm using the whole entire parabola. This is how we're looking at these tables and graphing these parabolas, these quadratics. Now, obviously, if you were using Desmos or using your calculator, it would have your exact y values. The only reason that I used only the height given is because I had a limited space. All right, so let's look at the next one. I want to make sure that I take note, and you have these notes in your notes page. You always label your axis so it matches the scenario or the situation you're working. You want to make sure that all data points are plotted. And when you plot your points, you want to look to make sure that the data matches what is appropriate for the scenario. Obviously, we would not have, in this last scenario, had a negative height. So you can't go under the ground. So you always want to make sure that the data points that you are plotting and looking at match what's going on in the problem. So it's time for you to do some mastery. A soccer player punts the soccer ball into the air during practice to get it down the field. The graph below shows the function that represents the height of the soccer ball with respect to time. What is the maximum height of the soccer ball reaching after it's kicked? It should say after. I do apologize, guys. It should be after. All right, so I'm going to let you work this one. I'm going to work it, and once you get done, look up here and see what you got. Does your information match mine? When I look at 0 minutes or 0 seconds, it's on the ground. He kicks or punts the ball, and it reaches the height of 7 meters. That's meters. That's why we always want to make sure that we read our graphs. That's meters. And at 1.5 seconds, it gets to the highest point, and then it falls back to the ground at 3 seconds. So we have answered that problem. We don't want to forget, we always want to make sure that we read through our tables and our graphs like I did when I thought it was feet, but it was meters, so that was a good learning point for us. We want to make sure that we're getting all the information that we can gain from those passages and graphs. We want to make sure that we are labeling our axis with our numbers and what those numbers are representing. We want to make sure that we are noticing where we're increasing and where we're decreasing in those intervals and what all of those intercepts are and what they represent. I'm so glad that you got to come today and learn with us. I had such a great time. I am Miss Killen. I want you to have a great day.